Good evening, all. Students, I request please inform your friends to join the session. We'll start exactly at 7:10. So before that, I request please inform your friends to join the session as soon as possible. Okay, we will start. Roshit sir, good evening.
Good evening, Sushmita.
Yeah, you can start the session, sir.
Okay. Students, I see a less strength. Please ask your friends to join fast. Like put in your WhatsApp groups and ask them to join fast. In the meanwhile, I will set up my whiteboard and then I will share my screen. Okay, so very good evening, students. Can I get a quick heads up in the chat box if you're there? Yes, I'm not getting any responses. Very good evening. Have you enjoyed your weekend? Did you do your assignments? What I have given? Yes, no. Chats are disabled. No, I guess I'm getting chats. I'm getting messages. Okay. So what we have discussed in the last class? What we have discussed in the last class? What we have discussed in the last class? Smita, can you enable the everyone chat? Smita, are you there?
Yes, sir. Please tell me.
Yeah, can you please enable that everyone chat? I'm not able to see their messages.
Yeah, I'll do it.
Okay.
2 minutes.
Yeah. Okay. So what is this is in the last class? We went to with the linked list, right? So we were discussing about the linked list. Then we discussed how to implement this linked list. We have designed this linked list. Yes. Good evening, Aryan. Good evening, Kajal. Yes, we implemented this linked list for insertion, for deletion, for insertion in the sense insertion at head and then tail. And we also discussed at position, right? And then we also discussed about deletion, right? The same thing we have discussed here also, deletion at head, deletion at tail, and then deletion at position, right? So this functionality we have discussed and we went with the reversing a linked list, right? We went with the lead code problem, that is reverse a linked list. Yes or no? Reverse a LL. This problem we have discussed, right? Then I have given you the assignment to implement your doubly linked list in the same way how you implemented the linked list. And then I asked you to two problems I have given, right? One is detecting a loop, and the second problem is palindrome, I guess. Yes. So okay. So today I will discuss one problem, that is detecting a loop in LL, which is from your assignment. Okay. There is one concept is there. I wanted to discuss that. Okay. And then I will be going with I will be going with stack implementation. Okay, stack queue implementation. Okay, stack queue implementations. This is using array as well. I will discuss using using array, using linked list, and using QR stack as well. One to each, one to one. Okay, vice versa also I will discuss. Okay, So this I will be discussing, and then I will discuss stack traversals. Okay, infix, postfix, and prefix. Those traversals I will be discussing. Okay, good evening, Sandhya. Good evening, Vinith. Okay, then I will be discussing. Then I will be discussing. Yeah. Then I will discuss one problem, like two, 1 to 2 problems on stack as well. Okay, 1 to 2 problems on stack as well, and the rest we will continue on tomorrow's session. Okay, so this will be the agenda for today's session for the next 1.5 hour. Okay, so are we clear with the agenda? Yes. Good evening, Santoshi. Good evening, Anurag. Good evening, Gita. Good evening, Amini. Good evening, Rani. Okay, so this is how we'll be discussing for today's session. Okay, so let's go to this problem. First problem, that is detect a loop, detect a cycle in a linked list. Okay, linked list cycle basically. Okay, so basically I've given this problem for assignment. Did anyone do it? Yes. Did anyone did? The effort should be there, guys. From my side, the 100% effort should be there, and from your side also, 100% effort should be there. What is too complex, Anurag? What is too complex? You will write the code in the chat, and then you will tell again complex. Means you are using some Google or some chat GPT and writing the code in the chat. Anurag? So linked list is too easy. Okay. Linked list is too easy. Just you are here in the case of C++, you need to learn pointers concept. There true pointers will feel it difficult, but here just creation of objects only. And then referring that reference variables. That's it. Yes. So that is not a complex thing. Okay. Anyways, like the if you're feeling it as complex, then you need to practice. You need to practice more. Okay, you need to check. You need to be logically practice more. Okay, then you will be able to combine. So I should give you 100%, and you should be giving me 100% by practicing at your side. Otherwise, the sessions will not be fruitful to you. Okay, when you practice what is taught in the class, when you're doing the assignments, what is being given, why I'm giving the assignments for the practice only for the next like I this is only 1.5 hour to me to teach you, right? So in this, how many problems will complete? Mostly max to max will complete 3 problems or 4 problems. But based on these problems, I am giving some assignment like 3 problems or 2 problems per day. So since it is a weekend, I have given you 2 3 problems, right? So that you need to take care, you need to practice those problems. So why means those problems which I am giving, those are the blueprint of what is taught in the class. That will be kind of a practice to you, extra practice to you, rather than giving to just practice, rather than giving the same code and telling you to put it on the id or practice it. You will not at all practice because you will feel like you got it something in the class itself by to practice. So that's the reason why I'm giving a model questions to you to practice at your end as well, so that you will understand more. Okay, so coding comes only through practice. One thing, make sure in your mind, at any case, you are 5 years experience, you are 10 years experience, you are 15 years experience, whole lot of whole of your software career. If you were doing coding, then definitely you should practice at any age. When you are 50, 55 also, if you are doing coding, then you should practice it. Otherwise, you will forget it totally. Okay, So daily, consistently, if you practice, you will remember for long. Otherwise, you'll forget it. Again, from starting, we need to start from day one again. This is the 10th, this is the 11th day. So we need to start from again day one. If you forget. So that will happen definitely. You'll again go to another sessions, you'll again listen the same. That will be in a loop. Okay, so make sure you are practicing it, you are consistently doing it this time so that you continue further in the next sessions. Like that, you should do it actually. Okay, so I'm not telling only to Anurag, all of the students here. Okay. Okay, so see here, the problem is linker list cycle. So basically, given head, the head of a linker list determine if the linker list has a cycle in it. So basically, in any linker list problem you take, they will not be giving you linker list object or something. They will just give the head reference. Okay, they will just give the head reference. Head in the sense, the first point, right? The first node, right? That is the first node. If I give the first node to you, can you traverse to the end of the node? Is it possible? Sandhya, is it possible, Santoshi? If I give the first node to you, first node reference, can you traverse to the end? Can you traverse to the tail? Is it possible? Yes, right? So once I give the head reference, we will make this as temp or something. And then temp dot next, temp dot next, temp dot next. While temp, what you will write the condition? While, while temp dot next not equal to null. Then what you'll be doing, you can directly traverse it, right? So basically you'll be taking it as head is temp is equal to head, and then temp is equal to temp dot next, right? Temp dot next, like this you can traverse it. So in the problems also, in the lead code problems also, they'll be giving you just the head reference. Okay, using the head reference, you manipulate it using the temp, you manipulate something in the temp and return the, you should also return the head itself. Here they were asking you to return true, but in some cases they will ask you to return the linked list itself. In that case, what you need to do, you need not to create all the objects. You can just return the head reference itself. You can just return the head reference itself, so that in the main method the driver code will be there right here. In the main method they will do traversing everything for you. Okay, any manipulation, you just manipulate it over your head, taking that head as an input, taking this in other problems, here they are given is boolean. Why here they are given is this problem will return true or false. In the driver code they have written such way. If they are asking you to return list node, then what you need to do, you should not create the list node whole object. You just return the head itself. You do the manipulation and just return the head itself. Okay. Okay, so what is asked in this question basically, like here is a cycle in linked list. If there is some node in the list that can be, if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node. The tail's next pointer is connected. Note that position is passed as parameter, is not passed as parameter. Return true if there is a cycle in the linked list, otherwise return false. So what this problem is telling, so if you can see here, 3, we are moving to the right, we are moving to the next node. Okay, then again if you see 0, then again 4 minus 4, again you are looping back to the 2 itself, and then again you are moving into 0, you are again moving into minus 4. Okay, then again you are moving back to the 2 itself. It's in a cycle, it's in a cycle, right? You, like here also if you see 1, you are going to 2 second node, again you are looping back to the 1, again you are going to the 2 circular linked list, right? You need to check whether in this given linked list there is a cycle or not. Like this, there is a cycle or not, you should be checking. If there is a cycle, you will be returning true. If there is no cycle, if the nodes are like this, there is no cycle is there, in this case you will be returning the false. You will be returning the false. Okay. Just you need to check whether there is a cycle in the linked list or not. Okay, whether there is a cycle in the linked list or not. Are we clear with the question? Yes. So can you tell me? So basically the question is asking, okay. So if suppose like this, the nodes are there. Okay. You do the problem, Anurag. You give me the approach, how I can do this. Think about it. Think about it. Santoshi is asking, Santoshi has did not understand, so I'm explaining again. You think about it. What is the approach you can do? What you can use it? Whether you can use stack or whether you can use array or whether you can use any temporary variable or you will use anything and you will feed it. You give me the approach. Why only every time sir only should think and sir only should implement? Okay. So if you can see here, 10, 11, 13, 14, 15, 16, 17. Okay. So you are starting at the head node. He has given that reference. You're starting at the head node. Okay. Then if suppose you are writing the temp node to traverse over this, you have visited 10. Okay. You have visited 11. You have visited 11. You have visited 14. You have visited 14. Then temp dot next. Again the temp is here. Temp dot next. Again you have visited 15. Again you have visited 16. Again you have visited 17. Again you have visited 13. Again you are visiting 14. See, again you are visiting at the 14. You started at 14. Again you are visiting 14 again. Again you will visit 15. Again you will visit 16. Again you will visit 17. Again you will visit 13. It is forming a loop. It is forming a cycle here. Linked list cycle here. So if there is a linked list cycle here, since why the uses is linked list cycle? Because you are if you are starting from 14, you are reaching again back to 14 only. You are not reaching to 10, like you are reaching to the same node where you have started. Where you have started, you are reaching to the same node. So if it is reaching like that, you should return true. You should return true. Got that? Yes. Suppose the node is like this. Is this a cycle? Can you tell me? Is this a cycle? Is this a cycle? No, it is not a cycle, right? So it is not a cycle, it is not ending in the loop. So basically, it will return me the false. It should return the false. Okay. So, so Anurag is asking, what if there are duplicates, sir? So you should not like here I have written number and I'm explaining, but the thing is you should see the node object, not the number, the data that is present inside. It can be 17, it can be 21, it can be anything. The data can be anything. You need not to worry about the data. In the question, they have not asked there will be 0 to n. There will be 0 to n. Like there is no nothing in the question like there will be only these numbers. Okay. They are just nodes. They are given just node objects. It can be anything. They can be anything. Okay. They can be anything. If you can see here, they are not given any constraints also. The node value will be in this range they have given, but the thing is that like they have not given the particular value will be there, and if the particular value is reached only, you should take it as cycle. Like that they have not given, they are just giving it as like they are just giving it as node object. You have visited the node object or not. Okay, once you have started from here, you visited the same node object or not. Okay, since for your understanding, I'm explaining through data. But the thing is, from here you are starting. if the node object is reached or not, the same node object that they were checking. Okay. So any solutions in this case? Any answers? Any solutions in this case? So I got a solution from mod. We can do it with asset maybe. Okay, asset basically it is nothing but a set, right? It is nothing but a set. You will add the data or reference, right? You will add the data. You can also do like that. That is fine because you will add just the node references here. If the node is present, or if the same reference is present in the asset or not, you will check. Okay, if the same reference is present or not, you will check. But anyways, duplicates will be going off. Okay, in set duplicates are not allowed, so only the unique elements will be there. But the thing is the references will be still be there, but you need to again check whether that element is already added or not. If hs dot contents of your node, that particular temp, you will check it up. Asset will also work. Okay, asset will also work. Mm, for easy understanding, I will take a hash map. Okay, I will take a hash map. Okay, so if suppose I will take a hash map, I have visited this node 10. Okay, I have visited this node. I will not insert the data. I will just insert this reference. Suppose this node reference is suppose like temp. Okay, this node reference, just node reference in the sense node will be having some address, right? Some address will be there, right? For this, some address will be there, right? If I'm inserting temp in the sense that will have some address, right? I will start the loop from here. Okay, I will start the loop from here. Fine, like I will add it into the asset. Okay, I will add it to the asset. I will tell it as visited one, visited. Then I will iterate the temp to this point. Then again I will push it into the asset. hm dot put of your temp comma 1. Okay, again I will add that temp reference of 11 here, the second node. Okay, 1. Then again I will add 14. Then again I will add 15. Okay, like this it will go. Okay, but before adding I will check whether the reference is already added or not, whether that is one, if it contains or not I will check. Okay, whether that is equal to 1 or not I will check. Okay, if it is added or not I will check first. Okay, so now what will happen, I'm adding all of them into the asset temp. Yes, we will check whether it contains or not, or else I can also check with the value also, get using get method. Okay, so I will check again temp. Now if you reach this point, this has been already added, so what you should return, immediately you can return the true. If it is not added, you will add it up into the asset. If it is already added, you will just return it as a true, or else you will return it as false. If you can see this one is added, this one is added, this one is this one can be added because this is not there in the asset before, and then this can also be added. Now in this case what will happen, like it will not contain anything, so in that case at the end you can return just false. You can just return false. So what you will be doing, let me write the pseudocode. Yes, exactly. It is equal to temp. Okay, it is equal to temp. You will write a hash map. Okay, you will write a hash map. You can write it as node. Okay, node comma int. Okay, node comma int for your value, and then map is equal to new hash map. Okay, map is equal to new hash map. Okay, then while tempo dot next, you will run the loop until null, right? While tempo dot next not equal to null. Okay, then inside this you will be checking if hm your map dot contains of temp. Okay, this is not condition. Okay, if it is not contained, then what you will do, you will put it in the inside the map dot put of temp comma 1. This will be adding. Okay, temp comma 1. Then you will be doing, okay, temp is equal to basically. Yeah. Okay. Okay, that's fine. Then you will be doing the temp is equal to tempo dot next. Temp is equal to tempo dot next. Else, what you will do, if it is already added, then what you will do, you will just return true. Okay, this is inside the loop. If it is not there, then you will return the false. You will return the false. So this is the thing, you can do it up, right? So what is the time complexity of this code? Time complexity of this code. In the worst case, you will return all the nodes, right? You anyways, if it is to check the loop also, you will be traversing over each and every node, right? At least once you will traverse. So for that reason, the time complexity will be big O of n, right? And then space complexity. In the worst case, when there is no loop, when there is no cycle, right? When there is no cycle, you will add all of the nodes into the ash map, right? So this is also big O of n. Okay. Can we also do this by using two pointers? Yes, absolutely. I'm coming to the next solution that only. Okay. Okay, here it is. Space complexity is big O of n, whereas time complexity is also big O of n. Okay, but this is not the efficient solution. Okay, this is not the efficient solution because we are using extra space. We are using extra space. So in the question itself, they have asked, can you solve it using big O of 1, using constant memory? Okay, constant space complexity. Can you solve it? They were asking this. Okay, can you solve it in big O of 1? Okay, so we can solve it in big O of 1 using, we can also call it as two pointer method, I can call, or else I will also introduce one another concept method, that is tortoise and hare method, or slow or fast pointers. Slow, fast pointers. Okay, slow or fast pointers. So let me, okay, so let me draw this up again. 1, 2, 3, 4, 5, 6. Okay. Okay, 10, 11, 12, 13, 14, and 15. Okay. Using this methodology, I can do this. Okay, slow or fast pointers are tortoise and hare method, or two pointer method. Okay, so basically what this algorithm tells is you take slow and fast pointers. Okay, you take slow and fast pointers. Slow will be moving only one step. Okay, slow will be moving only one step, whereas fast pointer will be moving two steps ahead. Every time it moves two steps ahead. Okay, so basically tortoise will move slow, right? Whereas I will move somewhat faster, right? So here tortoise I'm moving it by one step, whereas I will be moving by two steps. Okay, so at the head position, I will be putting slow and fast pointers first. Okay, and then what I'll be doing, this slow pointer I will move just one step. Okay, slow. Okay, then this fast pointer I will move two steps. Okay, two steps in the sense one and then two here. Okay, then again slow pointer will be moved one step, then again fast pointer will be moved two steps. Okay, then again slow pointer will be moving one step, then again fast pointer will be moving two steps. If you can see here, slow and fast pointer are matching at the are being at the same point now. Have been at the same point now. In this case, I can take it as directly written true. When fast and slow pointers were at the same point, if they were there, okay, if they at some point of time if they are coming together, in that case I can directly return the true. The linked list is in cycle. Okay, the linked list is in cycle when they were matching. Okay, when they were matching. Okay. Okay, when they were at the same point, I can directly tell this linked list is in cycle. Okay, but how should I stop it? How should I stop looping this? Because this will again move to here, this will again move to here, like this it will go on, right? So how should I stop it? What is the base condition? Okay, how should I stop it? So if you can see this, if I will write a if I'm writing a non-cycle linked list, if I'm writing a non-cycle linked list, okay, I'm writing this also even and odd. Okay, here I'm starting slow pointer, fast pointer. Okay, slow will be one step and fast will be two steps, right? Then slow will be one step, fast will be two steps. If you can see here, if you can see here, fast will be here now, means it is reaching the null. It is reaching the null. Yes, if both are at the same address, then exit. Returning true in the sense that means only, right? Then exit. Okay. But the thing is, in the case of your non-cycle, I'm explaining. In the case of your non-cycling, if you can see, when the fast is at null, when the fast is exceeding here, so means here it is not a no, it is not a cycle. So we can return directly false. We can return directly false for this case. Okay, when fast double equal to null. In the case of your even number of nodes. If you can see this one, let me do another 5 also. Okay, now you see slow, fast. Slow will be moving by one pointer, fast will be moving by two pointers. Slow, fast. Okay, slow and fast. Now if you can see here, if you can see here, if you can see this, after this node it is null, right? After this node it is null. Okay, after this node, it will move to the null itself anyways. So in the case of your order, you can take it as fast.next, fast.next double equal to null. Okay, fast.next double equal to null, then return false. Okay, this is in the case of your even, this is in the case of your odd. Are we clear? Yes. Are we clear? Okay, can you write the solution of this? Can you do it in the lead code? I'll be sharing this with you. Okay, the link as well. Can you try doing this solution? Can you try implementing this solution? I'll be giving 5 minutes of time to you. If you have understood the algorithm, just implement this. Don't look at your Google or don't look at any chat GPT or something. You did not understand the algorithm, then ask me again. Okay, but try to implement this using this algorithm. I will give you 5 minutes of time. Please try to implement it and let me know once done. Sir, all test cases pass, sir. Like that, you keep it the message. But don't cheat, okay? Just if you are not understood the algorithm, again you ask. I will explain. Okay, but don't search from Google or something. Okay. Everyone understood, right? This algorithm? Yes. Please try to implement it. Okay, good. Mangesh has done. Anyone done still? All test cases passed. Just don't put the solution here. Just tell us all test cases passed. That's it. That is fine. Right. Okay. Anurag has done good. Okay. So what you'll be doing? Uh, you can take a fast pointers. Okay. Fast is equal to head, and then slow is also is equal to head. Okay. Then fast is head and slow is also head. Then what you can do? Like if suppose there are no nodes, okay, there are nothing as given, then you can directly return the false, the base condition you are checking, return false. Or else, anyways, you will return it in the end, right? That is not required to check also. While past not equal to null, and okay, and slow and pass dot next not equal to null, okay, and slow also you can check head also, head not equal to null. Okay, then what you'll be doing, fast, so slow is equal to slow dot next, okay, slow dot next, fast is equal to fast dot next, fast dot next, okay. Then you will check if any point of time, at any point of time, if slow is double equal to fast, then you will just return true. Okay, you will just return the true. Okay, otherwise what you will do, for every condition you will just return the false itself. Okay, are we good? Yes. So let me run this. I need to sign out what? Sign in. It got loud out.
It's 8 o'clock.
Okay, I will click it as separate for it only. Okay, it is list node, right? Not node. List node. Okay, passed. Then if I click on submit, okay, passed. Okay, so this is how you will be doing this. Okay. Are we clear, everyone? Yes. I am sharing this solution to you. You can try it out. Okay. So next two problems. We are going to implement the stack now. Okay, stack and queue. Let's move into the next data structure. That is stack and queue. The last linear data structures. Okay. Stack and Okay. So what is stack? What is stack? What is stack? It's a LIFO data structure, right? Last in, first out. Okay, last in, first out. The one data that you are inserting in the last will be retrieved first, like your CD rack. Okay, you have your CD racks, right? In the olden days, we used to gather this. I used to generally gather this CD rack, like CDs. I used to love the CDs. So I used to take CDs and I used to put it in the rack. So what will happen? So the one which is the latest movie will be on the top, and then we'll be having the second movie, third, fourth latest movie, like that, right? So yeah, so this is how the stack will also work. So one which is inserted in the last will be retrieved first. Okay, and insertion and deletion can be done anyways from the top end itself. From top end only you can insert, from top end only you can delete. Okay, so basically we will call the insertion as push operation. We will call the deletion as pop operation. If you wanted to get the top of the stack, you can call it as top, or I can also call it as, in Java terms, you can also call it as peak. Okay, and then push pop, if you wanted to get the size operation, you can get the size method as well. And there is also another methods like is empty method is there to check whether the stack is empty or not. Like that, there are like different methods are also there. Okay, so we can also call it as LIFO data structure or FILO data structure, first in, last out. Okay, there is only one end to the stack, that is top end. Okay, there is only one end to the stack, that is top end. Are we clear until this point? Yes. Yes, insert and delete from top end itself. Okay, so this is how it will work. One moment. Okay, so this is how it will work. So if you can see in Java, you have the collection class already for stack as well. Okay, it's a legacy class actually. Stack implementation is already done, and if you can see, you can also check what methods are there. Okay, so java.util, before inside this. See, this is the stack implementation, and if you can see, we have the push already there, and the pop. You can directly call these methods by creating the objects. You can directly call these methods, and you can use this inside your lead code problem. Okay, these are all the predefined methods. You can use it inside directly your lead code problem. You need not to implement. Okay, but if they are asking to, if they are asking to design the stack or implement the stack, then definitely you need to implement. Okay, so if they are not asking you, you can use the predefined methods anywhere. Like suppose sorting, they will only like sorting also, arrays.sort method is there. Okay, in collections also you have the sort. You can also sort it using comparator comparable. Okay, in Java. Okay, so if they are not asking, you're free to do the task. Okay, until they tell, don't use it. Until they tell, don't use the sort predefined function, you implement by your own. Until they tell that, you can use predefined methods that were there to make your work easier. Okay, don't sit like the interview will be there for only 45 minutes. Okay, please remember that. If you keep on implementing the stack, push, pop, and then you're using the method to push into the stack, then you're using inside your lead code problem, the time will not be sufficient to you to write the code. The interview will also not feel you are efficient. Okay, time will not be sufficient, as well as the interviewer will also not feel you efficient, since you are writing large amount of code. They will not treat you like you are a pro in coding. No, They will think like they're in the mind already. These all implementations are already there in their mind. These are simple operations. Implementations are simple. Okay, so in that case, you should you should use a predefined operations and just solve it inside your, because there is a time constraint there. If they were telling to specifically implement the stack, or specifically implement some sorting, or specifically implement some linked list, they were telling it, then only you should implement it. Okay, otherwise time won't be will be sufficient for you. Okay, so yeah, Anurag, go ahead. Okay, so if you can see, stack in the sense last in, first out, and there will be one end, that is top end. So in Java, you have already the predefined functions, you can use it up. But if they ask you to implement, how you should implement. Okay, if they ask you to implement, how you should implement. You can implement the stack using array as well. Okay, using predefined structure, that is arrays as well, using linked list as well. Okay, using linked list as well. Okay, and using queue as well. Queue also you can take and you can implement it. Okay, so first one, arrays, how you will implement it. So suppose I'm taking an array of some size. Okay, some stack. Okay, int array stack is equal to new int of some 10. I'm 15. Okay, some 15 I'm taking. Okay, so now I wanted to do all these operations. St dot push of 10, st dot push of 17, st dot push of 19, st dot pop. Okay, st dot pop. Then st dot push of 23. Okay, then I wanted to retrieve the top element. Then again I wanted to do the pop. Okay, st dot pop, and then I wanted to do again the top. Okay, like this I wanted to do. Okay, these are all the operations I wanted to do. Okay, now I am taking a stack of some 15 size. You take it as this one is 15 size. Okay, there are like 15 elements, you can put it up inside the stack. Okay, this cannot be 15, but you take it as 15. Okay, now I want to perform the first operation. Since there is only one end of the stack, that is top end. Okay, then how you will implement? You need to insert from the top end only. You need to delete from the, this is your top end. Okay, this is your top end. You need to insert from the top end only. You need to delete from the top end only. Okay, so for that reason, I am taking one top pointer. I will initialize it to -1. Okay, I will initialize it to -1. Now I wanted to insert 10. I wanted to push the 10. When I am inserting the first element, what I will do, I will move this top to 0th position. Okay, I will move the top here, and then I will insert the element, that is 10. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then again I'm pushing 17. Then what I need to do, you need to move the top pointer. To here, and then you can insert the 17, because last in first out, right? So for that reason only you are moving this top pointer, which is inserted first. If you suppose the very next operation is pop, then you should be in a position to immediately delete it, right? So that reason only I'm moving this top pointer. Okay, then again 19 you are inserting. Again you are moving the top to here to second position, and then again you are inserting 19. Okay, then again I'm inserting here, there is a size operation is also there, suppose. Okay, then again you are inserting 19, and then you are popping it up. Popping in the sense, the top element that is there on the stack, you should pop it up. Means what will happen, this you should pop it up. So what you need to do, if you're popping, If you're popping, what you need to do, you need to move this top pointer. You should decrement this top pointer, right? From here to again here. Okay, because this will become the top now when you are popped. Then again you are pushing. It will become 23, right? So you need to move the top pointer here. Again, you need to move the top pointer here. Again, what will happen? Here it will be 23 now. Okay. Then if you can see, if you want the top element, what is there on the top element? You will get what? What element you will be getting here now? What element you will be getting here now? You will be getting what? You will be getting 23, which is there on the top. And then if you are wanted to pop, again you are popping it up. Means now what you need to do? Again you need to decrement the top pointer. Okay. Then again, what is the top element now? What is the top element now? 17. It will give me the 17. Okay. Then if you wanted to get the size of the stack now. What is the size? Size is now? Size is 2, right? So top is at first position. So can I take it as top plus 1? Top plus 1. Yes, this will be the size. Okay. So this is how you can implement your stack. You can implement your stack. So what is the pseudocode? What is the thing you will be writing? So you should implement your stack. So you can take some class stack implementation. Okay, stack implementation. Okay, and then you can write int top is equal to -1. Okay, and then you will have the different functionality, right? Push of int x or int element. Okay, so what you'll be doing, what you should do for pushing, you should have a size of stack as well, right? Stack size, which is new stack of new int of some 10 or 15. Okay, then what you'll be doing, before pushing you should also check, you should check one before pushing you should also check whether if if stack, if top your if top, okay, you should also check if top double equal to stack dot length -1, stack dot length -1. Then in this case stack is already full, then you should return it, right? You should return, you can return it as already full, already filled, means overflow condition will happen. So already filled, nothing can be inserted. Okay, like this you can pass the message to the user. Okay, otherwise what you can do, if it is not full, then you can directly st of top plus plus, st of top, okay, plus plus of top, right? Plus plus of top, not a plus plus, plus plus of top, because you know the difference, right? Plus plus pre-increment and post increment. Yes, so post increment in the sense first operation will be performed, means first insertion will be performed and then the increment of top will perform. So plus plus of top is equal to x or element. Okay, so this is how the push operation will work. Then pop operation, can you tell me? Pop operation, just you need to do top minus minus, right? Then if you wanted to get the size or if you wanted to get the top element, what you will do, return stack of top, return stack of top, right? If you wanted to get the peak operation or top operation, right? If you are if you wanted to return size of the stack, Then now you will be return top plus 1. Return top plus 1 means this is the index, right? So size will be plus 1 always, right? So return top plus 1. So this is how the stack functionality you will be writing using the array. You will be representing within the array. Are we clear until this point? Yes. Okay. Next one queue. Okay. Next one I will implement queue. So queue, how does it work? How does it work? How does it work? FIFO, right? Like your movie ticket queue or your bus ticket queue or your train ticket queue, right? First in, first out. Whoever enters first will be deleted first. Whoever enters last will be deleted last itself, right? So basically, if there is a queue here, there is a queue here. Then from rear end, I will insert the elements. From front end, I will delete the elements. From front end, I will delete the elements. Okay. So this is how the queue will work. Here, the push operation, you can also call it as enqueue operation. Okay, enqueue operation. The pop operation, you can also call it as deleting from queue. You can also call it as dequeue operation. Okay, then top is nothing but you can call it as peak, means what is there on the front, you will get it up, and then size like that is empty. Those are all things for that. Okay, so for queue also, there are like multiple implementations over there inside your collection class. Okay, if you go to your instead of queue, if you write queue, okay, I wanted to go here. See, why I'm not able to get it there. Okay. Okay, if you can see, queue is an interface. Queue is an interface. Inside the interface, we have all the add method, offer method, remove method, poll method, element method, peak method. Okay, element method, peak method, and if you can see the element method also does not remove that of this queue. This method only differs from only in that queue. It throws an exception if the queue is empty. That means from peak operation, this will throw an exception. If suppose the element, if the queue is empty, it will throw an exception. This peak will not throw any exception. It will just give null. Okay. So this is how, if you can see the implementation also, you can go ahead and see. Open implementation. See, these are all the implementations. See, it is asking which implementation I should open. See, they have implemented like abstract queue also. They have implemented like array blocking queue, concurrent linked queue, linked blocking deck, linked transfer queue, priority blocking queue, priority queue, concurrent linked queue. Like that, they have double-ended queue. Like that, different ways they have implemented the queue. Okay. If suppose if I go to some array blocking queue itself, okay, and if you can see the add operation, see, open implementation. And here also, suppose I wanted to go with array blocking queue itself. Super, what is super? Okay, like this, there are like different implementations over there. Okay, so like this they have implemented. You can directly use those methods as well by creating the object of the queue class. Any of the implementation class you can take it up. You can take priority queue, you can take double-ended queue, you can take array deck. Any of the implementation class you can take it up, and you can use it in your lead code problem. Okay, if they are not asking about the implementation, but if they are asking about the implementation, again queue can be implemented using array implementation. It can be implemented using linked list implementation. It can be implemented using stack implementation as well. Okay, it can be implemented using stack implementation as well. Okay, now array implementation. How you are doing the array implementation? So basically, I will take two pointers. Again, the same. I will take some 7 elements. Okay, queue size into queue size is some 7. Okay, 7 elements I will be taking. Okay, 1, 2, 3, 4, 5, 6, and 7. Okay, now I will take two pointers for this start and end. Okay, so since there is a top end is there, there is a rear end is there. From rear end I will insert the elements, from front end I will delete the elements. Correct, Sandhya? Okay, so what will happen? I will point both of them to -1. Okay, I will point both of them to -1, and then I will take some operations, push of 23, push of 19, then again push of 25, then pop, then push of 37, then pop. Okay, then pop. Okay, and then many elements are there. Then I wanted to get the top element, then I wanted to get the size as well, and then again pop, then again I wanted to get the size. Okay, so many operations: 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, 10, 11 operations I wanted to do here. Okay, so I wanted to insert 21. So what will happen now? You can take start also, you can take end also, you can also take front also, you can take rear also. Okay, let me go with front and rear only for your easy understanding. Okay, initially front and rear, you will point it to -1. Okay, now you are inserting 23. Okay, so when you're inserting the first element, you will move this front and rear pointer to element 1. Okay, 0th end. Okay, 0. Don't worry about attendance, Mangesh, you will get that. Okay, you will get that by 9 o'clock. This is the 11th day and you are asking again attendance. This doesn't seem look good. Okay, front and rear are pointing to the first element, and you are inserting the 23, and then you are inserting 19. Okay, you are inserting 19. So when you are inserting the second element, you will only move the rear pointer. Okay, you will only move the rear pointer. Okay, so rear pointer to here, and then 19. Okay, then again 25, then again you will move the rear pointer. Okay, you will again move the rear pointer. So whereas front pointer will be at the start itself. Okay, then if you wanted to pop, means this what you should pop. You should pop 25 or you should pop 23. If you pop 25, na, they will hit you like anything. Okay, because this is a queue, this is not a stack. The stack is nothing but CD racks. Those are your favorites. You can pop it up to the latest. But if you pop 25, na, they will hit you like anything. The other people, 23 and 19. So what you need to pop? The front one. Okay. So front will be moving to the step. Okay. Then again, what you are doing? Push off 37. Again, you are moving the rear to 37. Okay. Rear to 37. Okay. Then again, you're doing the pop. Pop 37 or 19? 19, right? So front will be here. Front will be here. Okay. Then again, what you're doing? 37. You're doing the pop. Okay. First pop is done. Second pop again you're doing. Means again the front will be moving to here. Okay. Now what is the size of the stack? The size of the stack is 1. The size of the stack is 1. How you will do the size? How you will do the size? So basically the size of the entire stack is 6, like it is some 1 to like 1 or 7, right? But what is the current size after popping? What is the current size? It is 1, right? So you need to take care of this also. You should track current size as well. How much is it? For every insertion you will do plus plus. For every deletion you will do minus minus. You should track care. You should track of this current size also, so that you can return it. You can return just the current size when the top is asked. Okay. So if this is a top in the sense, what will be written? Top in the sense, what will be written? Top in the sense, what it will return? You should return the front one. What is there on the, like, you should return your rear end, right? So which is there on the front side, that is 37. Okay, you should return your front one, that is 37. And then size, so size is here, current size, that is 1. And then pop, again what you are doing? You are removing this pop. Okay, you are removing this pop again. So now what will be happening? So when you are removing it, so when the stack is empty, when the queue is empty, okay, when the queue is empty, then what you are doing? When it is the last pop, means this is empty. So in this case, you will again move the front and rear pointer to -1. Okay, front and rear pointer to -1. Okay, again you will move the front and rear pointer to -1. You will go and insert from starting again. Okay, resizing. Okay, suppose I have increased the size here. Suppose there are like 3 elements are only there. Okay, there are like 3 elements. Okay, 4 elements, I will take it up. Okay, suppose push I am taking. Okay, then again push. Okay, then pop. Okay, then again pop. Okay, then again push, then again push. Okay, some 1 2 3 4 I'm pushing. 1 2 3 4 5. Okay, then again I'm taking the top as well, again I'm taking the size as well. Okay, so initially push and like front and rear will be -1, right? Front and rear will be -1. Now you are inserting 1 here. You are inserting 1 here. So what will happen now? Front will be here, rear will be here, and then you are inserting 2 again. Okay, when you are inserting 2 again, then what will happen? Like front will be, like rear will be incrementing, right? Front will be staying here itself, rear will be incrementing, so rear will be going here. Okay, now you are inserting 3 again, the rear will be moving here. Okay, again pop you are doing, pop in the sense front plus plus, right? So front will be here. Okay, Then again this place is empty, right? Then again you are doing the pop. Again this will be removed. Again this will be here, right? Again you are doing the pop. Mhm. Okay, this is done. This is done. Okay, now front is here. Again you are pushing it. Okay, you're pushing the element. Means now rear will be here and pushing 4. Now you see again you are pushing it. Again you are pushing it. So is there any space here? Is there any space here? While pushing also you will check whether the size, whether the current size is increase, like your size is exceeding or not. Okay, it is greater than or equal to or not, you will check, right? So is it now where you will be placing the elements? Is the queue is really empty? Is the queue is really empty? Or like really can really full? Is it filled? No, right? Like two positions were there. But the thing is, since you are incrementing, only increment the rear pointer, you should, if you increment, it will move to the null, it will exceed. So in that case, but the queue is not full. So what you can do when it is exceeding, when this rear is exceeding the size, then what you should do? You can move the rear pointer again to the front, again to the zeroth position. Okay, again to the zeroth position, you will insert the 5. Okay, then again you can insert, means from front to rear you can think. So now if you wanted to pop, again you will insert some 6. Okay, again you will insert some 6. Again you are inserting some pop, you are doing the pop. So now what will happen? 6 will be coming here, rear will be here, and then you are doing a pop means what will be deleted? 3 will be deleted, it will move to the front. Again you are doing the pop, again you are doing the pop. Then if you see, this will be deleted and front should move forward, right? But here it will exceed the size. Then what you need to do? Again you should move to the zeroth position. Again you should move to the zeroth position. Okay, so basically you will be moving to the zeroth position. Okay, so like this you will iterate over it. Well, like three conditions basically here. So what were three conditions? If everything is popped, if everything is popped, if everything is popped, then you need to move your rear and front to -1. Okay, if suppose something is popped, the rear is exceeding, or if front is exceeding, rear or front is exceeding, then what you will do? You just move a rear plus 1. Okay, rear plus 1, you will use this formula to move to the front. Okay, you should move to the front, right? So rear plus 1 percentile by size. Okay, percentile by size of your queue. So basically rear plus 1. So if you can see front has moved, right? Front has moved. In that case, what you need to do? Front plus 1. Front in the sense, front is at how much position? It is at 0, 1, 2, 3. Okay, 3. Okay, 3 plus 1, which is nothing but 4. 4 percentile by 4, which is nothing but 0. Means it will go to the 0th position. Like this, you should determine the size of your rear and front positions. Are we clear? Yes. Where you are not clear, Anurag? Where you are not clear, please let me know. I'll explain again. Okay, stack is of 4 size. Okay, queue is of 4 size. Okay, 0, 1, 2, 3. Okay, you are pushing 1. Okay, you are pushing 1. So what will happen now? Front and rear will be here. Okay, you are pushing 2 means only rear you should move forward. It will be 2. Okay, then push off 3. Again, what you need to do? Rear here and then 3. Okay, and then you are doing the pop operation. Pop in the sense what it should happen, the front element should be deleted, so means front will be moving here. Okay, are we clear? Yes. Then pop again, then pop again. Pop in the sense again 2 will be moving, front will be here. Okay, so the until this point that is done. Okay, then push off 4 you are doing, means rear will be here, 4. Then again push off 5 you are doing. So generally what we are doing, if I wanted to insert 5, so we if rear plus what will happen? It will exceed the size. When it is exceeding the size, we may tell the queue is already full. Okay, queue is already full, but it is not at all full. The like already there are some elements are there. Okay, there is some space is there. So in that case, what you should do, you can you can do you can implement this formula. You should move the rear to the front. Okay, rear plus 1 percentile by size. Okay, when it is reaching the size, what you can do, you can move to the starting again. So rear plus 1 in the sense 3 plus 1, 3 plus 1 percentile by 4, which is nothing but 4, 0, right? So again the rear will be moving here. Until this point clear? Yes, until this operation clear? Then again you will move the rear pointer to here. You will again move the rear pointer to here. So here it will be 5. Here it will be 5. Here it will be 6. Okay, 5 and 6. Then again pop. Pop in the sense what will happen? The front will be deleted. Right? The front will be deleted. So front will be coming here. Okay. Then again if you are doing the pop, then what you should do? There are elements are there, it should not exceed, right? So in that case you should move this front to again this at this point. So front plus 1 percentile by size, so front will be moving here. Okay, front plus 1 percentile by size, like this it will move it. Are we clear? Yes. Size percentile by size, if we do how it will come for every case. Here it is 0 means it's okay, but based on the rear it should go, right? Based on the rear it should go, right? Based on the front position it should go, right? Okay, let's implement the logic. Give me one moment. Give me one moment. Okay, so let me implement this. Main method. The Q, right? And the Q is equal to new int of something. I will take it as some 10. Okay, or we have take it as only 5. Okay, then int print is equal to -1. Okay, and rear is equal to -1. Okay, then what I need to do, I should implement my functions, right? Take it up here. Okay, then void push of an element. Okay, the user is passing some element. I need to be inserting into the queue. Okay, the user is passing some element. I should be inserting into the queue. Okay, so how I should insert basically. So first I should check. I will be taking one size as well. Okay, I'll be taking some size as well, like some current size. Current size is equal to 0. Okay, then if like if suppose current size is already okay, current size is already equal to size, then what you can do, you can just simply return. Okay, you can just simply return if current size is equal to q dot length. If size is equal to q dot length. Okay, I'm taking this as size itself. Okay, if it is equal to size, then what you should do, and directly put it as like it is already filled. Okay, then what you can do, if it is not filled, then you will be inserting into the stack, right? Again, you should also check if current size is double equal to 0. If it is the first one, then what you need to do with the first one, then you will be taking rear is equal to 0. Okay, top is equal to 0. Okay, rear is equal to 0. Top is equal to rear, your front is also 0. Okay, else what you will be doing. Okay, else what you will be doing, just you will be inserting q of rear. Okay, rear, q of rear plus plus. Okay, q of rear plus plus of q of rear, right? Plus plus of q of rear is equal to your element, right? Element. But is this correct? Is this correct? No, because it will exceed when it is overflown, when the push condition, when the stack size is already like it is exceed, the rear will also exceed in this case, right? So when the pushes are more, then it will exceed. Since the size is also empty, it will not give, right? It will return. That's it. So for that reason, what you need to do, you need to go with the rear size as well. You need to find out the rear size. So you'll find out the rear size, rear plus one. percentile by size. Okay, rear plus 1 percentile by size. Okay, then you can directly put this up here instead of rear. Okay, q of rear is equal to element. Okay, so this is how you will be doing within the push operation. And then what you can do, for every push you can increment the size as well, size of your stack, current size plus plus, current size plus plus. Okay, so this is how you will do the push operation. Then pop operation, void pop. What you'll be doing, void pop. So what you need to do, basically you need to decrement the top, but for that reason also you should again find out the top. Or first reason, what you should check, you should check if current size is 0, then you will have no elements to pop. Okay, then you will have no elements to pop. In that case, what you can do, you can directly return. Okay, otherwise what you will do, otherwise what you will do, if current size double equal to 1, there is only one element is there and you wanted to pop it. So I've given this condition, right? I've given this condition where front and rear is there is only one element as there and you are popping the 37. Then what you should do, you should move the front and rear to again -1. Okay, move the front and rear to -1. So front is equal to -1, equal to -1, rear is equal to -1. Okay, this is how you will be doing. Else what you need to do, okay, else what you need to do, you can decrement the top value. But how you will decrement the front value, again you will write the same thing for the stack as well, for the front as well. Front, okay, here also front. Okay, front plus 1 percentile by size. Okay, then q of front, q of front is equal to element. Okay, you nothing to do that, right? Just you can directly do the current size -1. Okay, current size minus. Okay, this is a pop operation. Just you will decrement the size. Okay, if you wanted to get that, if you wanted to return the element also, you can take that. You can take that element here. If you wanted to get q of front, what you are popping that you wanted to return also, you can return it. Okay, and then next one is returning the top. Okay, int top, how you will return the top element. If you wanted to perform the top element, if you wanted to return, then what you can do, you can directly return the q of front. Okay, q of front. And if you wanted to return the size, current size, directly if you wanted to return the size, the current size of the stack. Okay, current size of the stack, if you wanted to get, what you can do, return. Okay, return current size. Okay, like this you can return it. Now let me check whether this is working or not. Let me, okay, directly I will call the push operation, push 15. Okay, we cannot call it directly, so what I should do, I should create an object of this class. Since it is, they are not static, otherwise I will make it as static itself. But static, we cannot use these variables if it is static. So what I can do, I will create an object of this class, new main, new main one, obj, okay, obj dot push, otherwise I will take it as q itself. Okay, q dot push, Okay, I'm pushing it up. Then I wanted to pop it. Q dot pop. Okay, I will duplicate this. Okay, that is fine. I am popping it up. Then I am taking up the size of this. Q dot size. Q dot current size. Okay, this I will print it up. Q dot current size. Then I wanted to print also top element here. Top. I wanted to pop again. Q dot pop. Now if I try to execute this, it is giving 0, 0, 0, 0, 0, 15, 15, 15, 15, 15. 4 times I have taken Q as 15. Okay, then what I am doing, I am taking a pop for 3 times. Means these 3 elements were popped. Okay, and then Q dot current size should be 1, right? Q dot current size. So I will also write a condition here if current size is double equal to 0, then return. Okay. -1. Current size, it is giving like this current size plus plus, right? Okay, here it is giving Q dot current size as Q dot current size of 0. 3 times I'm doing, right? 3 times I'm doing, means it should give 1 right here. Okay, so but the logic is this one only. I'm giving this code to you. Just keep it in your editor and let me know where the mistake has been done. Okay, I am giving this to you. Just debug this code and let me know where the error has gone tomorrow. Okay, so yeah, the front is equal to -1 and +1, current size minus minus. Okay, when we apply push, then we update. Oh yeah, rare +1 I'm doing, right? Rare +1 anyways I'm doing. Front anyways will be at the same point. That is 0 itself. Okay. So let me know tomorrow, like debug this code and let me know where I'm making a mistake. Okay. So let me give you one assignment for the day. Validate parentheses. So this problem I'm giving is an assignment for tomorrow. Okay, please try to complete it. For today, I'm giving this problem as assignment. Okay, only one problem. Please try to do it. Okay, find some time and please try to do it. Okay, so on that note, thank you so much, guys. We'll continue tomorrow. Okay, have a good night.
Yeah, thank you, sir. Thank you so much.
Yeah, thank you, sister.
Yes, so dear students, attendance link is shared it on a chat. I request please mark your attendance without any fee. So Vinith is asking, please send the notes link. The notes, whatever the materials has been used, which is already uploaded in LMS dashboard, I request you to check in LMS. Okay, fine. Thank you all. We'll wind up for the day. Good night, everyone. Thank you.